Here we go. 2A.5 function transformation. We've broken down into 4-part notes. Today we're going to do part 1 and part 2. You're not writing this down. It's already in your notes. But part 1, we're talking about graphing functions using vertical and horizontal shifts.
Yeah, that's what I said. It's literally 4 parts.
I just told you it was.
What? Is this the last of it?
This is the last of it for this unit. This unit. All right, what I do want you to write at the top of your page. So on your notes, you're going to write this at the top. F of X. Well, All right, here we go. So at the top of your page, focus, lock in. You're going to write what is boxed. Do you see what is boxed up here? It says f of x minus h plus k. Okay, your h represents your horizontal transformation and your k represents your vertical transformation. So that's what you're writing at the top or bottom of your page, wherever you have the most room. Okay. So this is called our function rule 4. We're on part 1.
No, I was trying to figure out what this is.
Okay. What this tells us is how we're moving the function. The purpose of transformation writing is that you're not evaluating like you did in your do now. You're using the rules to move the function without plugging in things. Does that make sense? You're not plugging anything in, you're using the rules. So for example, if I had f of x plus k, so a function plus k, I know that I'm going to be shifting it either up or down, okay? If I have a horizontal transformation and it says f of x minus h, I'm going to be either shifting it up or down, and this is a typo, this should be a +4, but you're not writing this part, we're going to dive in a little deeper. What did I say? My bad, I meant right or left. Yeah, it says up. Down. It's a plus sign, you go left. Our x's are liars.
Oh.
All right, don't write it down. We're gonna write, trust the process. All right, here we go. So starting off with vertical shift. So when we have a vertical shift, that's when we're only looking at the f of x plus or minus our k value. Okay. So f of x plus or minus our k value. If it is f of x plus k, it's going to be shifted vertically up. Mathematically, what is happening is what we're going to write. That means we have y plus k. So we're going to add to all y values. So we're going to add to all y values of the original function. That k is going to bother me. Okay. Add to all y values of f of x. Okay. Now, if we are subtracting our k, so if y equals f of x minus k, the graph is going to be shifted vertically down. In order to vertically shift the graph, what are we doing mathematically? Well, we are y minus k. So we are going to subtract from all y values. Okay, I'll give you a moment. Once you see it in action, you will see that it's not terrible. Time is usually your x. All right, horizontal. Now, for horizontal, this is what we have to remember, that x's are liars. X's are liars. Okay, it's gonna look like one thing, but it's another. So this is when you have f of x plus or minus an h value. Okay, if you have f of x minus h, your graph is gonna shift horizontally to the right. Mathematically, in order to shift something to the right, what do you have to do? Add. So it's gonna be x plus your h value, which means that you're going to add h to all x values of f of x. Okay? If you have f of x plus h, it's going to be the opposite of what you think. It's going to shift it horizontally to the left. If I want to move something to the left on a number line, what do I have to do? Subtract. So it's going to be x minus h, and we're going to subtract h from all x values of f of x. Notice that I keep saying of f of x. That means from the original function. All right. Are we ready to do some drawing? And
No, but then we have option.
we don't, so I'm glad you know that. All right, so up first we're gonna do an example of vertical shifts. Remember this, I said you may need 3 colors for the day. All right, so first we're gonna graph our original f of x equals x squared, right? So f of x equals x squared, that means we're graphing a quadratic, correct? A parent function. So we're gonna use -3, -2, -1, 0, 1, 2, and 3. I'm on my red right now. So for the original parent function, we know that we have 9, 4, 1, 0, 1, 4, and 9. I squared them. Because isn't that what the function tells you to do? So it's to square your numbers. And a negative times a negative makes a positive. So I'm going to quickly graph this. Remember, you're always going to choose your smallest x values possible. You don't want giant x values. So we're graphing f of x or parabola, as it's formally called. It's called a parabola.
So what do we use?
X's and Y's.
Okay. X is a Y.
F of X is your Y.
Oh.
All I did was plot -3, 9, -2, 4, -1, 1.
This not.
I'm coming. All right, so all I did was graph the parent function for quadratic. That's it. We did nothing else. And all we did was square some numbers. Okay, we chose our smallest x's, plugged them in. Do we see that? All right, that's my f of x. Now I'm going to switch colors because it says it wants you to create the graph g of x, which is x squared plus 2. So I'm taking my original, my f of x, and I'm adding 2. Does that make sense? According to this, when we do this, that means that for g of x, our x's are staying the same, but to all of our y values, we're going to add 2. So we get 9 plus 2, 4 plus 2, 1 plus 2, 0 plus 2, 1 plus 2, 4 plus 2, 9 plus 2. And those are going to be my new y values. I'm not doing anything to the x. I'm only changing the y. So we have 11, 6, 3, 2, 3, 6, 11.
Okay.
A U? It's been a U the whole time. We literally just drew a parabola right now. All right, so I'm going to use the same X values, but I'm now using my new Y values. So what this is telling you that each point that I originally graphed is shifting up 2. So instead of being at 9, it's now at 11. Instead of being at 2, it's now at 4. Instead of being at 1, it's now at 3. Instead of being at 0, it's now at 2. I'm literally shifting each point up 2 units. So here's my quadratic being shifted up 2 units. So now this is my g of x. I'm going to pause now, and following what we did for g of x, you're going to use that knowledge and create h of x. Okay, h of x says your original f of x, but this time you're doing what? Minusing 2. And again, it's the original f of x. So you're filling that one in. Let me know if you need me. You can see why I said the colors may be helpful. All right, are you ready?
I'm not gonna lie. You didn't even like the flag. You just told us to do it.
I walked back here, took 2 bites of my burritos, sipped some coffee. I thought we were late.
You know, we got getting out fast, like, yeah, take a couple more bites.
Okay, I got it. All right. So what was h of x asking us to do? We're subtracting 2 from each one of our y values because f of x is y, correct? So my new points are what? There we go. So to all of my original points, my reds, they're all shifting down 2 units. You know, who knows what my computer wants to do? Where's -2 to? I'm ignoring y'all. And y'all just let me sit here and graph my graph all wrong. Yeah, my graphs are all wrong.
We're all on that.
Yeah. I was like, what am I doing? Who did this? You should be able to count without me. All right, guys. So I apologize. Let's blame it on the weather. I don't know what happened there. But for your green and your h of x, you're now shifting all these points down 2 units. So you, like you guys told me, 7, we're at 2, we're at -1, -2, -1, 2, and 7. So visually, what happened with, I can't even pretend that was good. I can't even pretend. Like, you know, I usually can lie to myself about my artistic abilities.
There's some.
They're curvaceous. Okay. All right, there we go. Okay, beautiful. So when we add to our y's, it causes it to do what? It shifts up is what we were looking for. When we add to our y's, we shift up. When we subtract from our y's, we go down. All right, horizontal shifts. Okay, so now we're on to horizontal.
Oh, all right. Oh, wait.
So this time,
You add to your the same X value?
yes, we're using the same x values. You want to use your smallest x values possible, right? I don't know why you want to put anything bigger, but if you want to be weird, go for it. I want to use my smallest possible ones. Okay. All right. So my x's are -3, -2, -1, 0, 1, 2, 3. And I'm plugging them into the absolute value parent function. What does absolute value do on our numbers? Makes it positive because it's just asking how far are you from something, right? And distance is always positive. So we're at 3, 2, 1, 0, 1, 2, and 3. So I'm going to graph my original function. So at -3, 1, 2, 3, 1, 2, 3. At -2, I'm at 2, negative. We're just plotting the points. And I'm going to put all the points to hopefully draw a straight line. Yeah, it's absolute value. All right, here we go. Connect the dots. Connect the dots. You can do it. Connect the dots. Oh. We got most of them. Yep. All right. So I needed the points to try to draw straight lines. So I need the dots. I needed it. Okay. All right. How do we feel about the absolute value parent function? Okay. Now we're going to do our first thing. It says g of x equals the absolute value of x minus 3. Notice how here I'm affecting the x. Okay. So for g of x, I'm affecting the x. So to find my g of x, what's happening here?
You're minusing, you're plusing 3.
I'm going to add 3. X's are liars. So we're going to add 3. So to each one of my x's, I'm going to add 3. And my y's are staying the same. I'm changing these, but I'm not changing those. So we have -3 plus 3, -2 plus 3, -1 plus 3, 0 plus 3, 1 plus 3, 2 plus 3, and 3 plus 3.
All right, don't go too fast now. I need to see nobody.
At this point, I'm just adding.
I forgot how to add.
Okay, so -3 plus 3 is 0. -2 plus 3 is 1.
3, 4, 5, 6, 7, 8, 9, 10.
And then we're at 2, 3, 4, 5, and 6. Okay, my y's are staying the same. So now I'm at 0, 3. So I'm going to go to 0 and go up to 1, 2, 3.
I'm using the same color.
Okay, the reason being is I took this guy and I shifted it to the right 3. Do we see that? I just plotted the point 0, 3. That's all I've done.
Oh.
I don't know what you're yelling at me for. I've only plotted 1 point.
Wait, this is the y, the f of x is the y, right?
Yes, f of x means y.
This shows that there's something wrong. I don't know how to do basic math. It's just too much going on, like. I put 1, 2, 3, 4, 5, 6. So I don't know why.
0 plus 3 is 3. 1 plus 3 is 4. You're the one who just said you didn't.
I just don't know why I messed. Oh. Oh, my stuff the 3 right there.
All right, did it shift to the right? Okay, guess what now? If you said it's your turn, you are absolutely correct.
Hey, leave me by myself.
Okay, so h of x is saying absolute value of x plus 3. What are you gonna do here?
You move it to the left. Subtract.
So therefore, you're doing what? In order to go to the left,
Yes, I'm getting it a little big.
you have to do what?
Subtract, I said that.
Subtract it from the original x's, right?
Duh.
Okay, just making sure we knew that.
I don't know to say duh now.
Making sure. 'Cause you'll be the first one hollering at me.
Well,
So,
well. It shows I lost myself again. Let me focus for it. All right, because I have my values in here.
okay. So now we're at -6, -5, -4, -3, -2, -1, and 0. Again, did I touch the y values? No, so my y values are going to be the same. So we're at -6, 3, and that's because I took this point and I shifted it 3 units to the left. I'm glad y'all say that. We do have a logo project after transformation, where you have to create your own logo
Tell me.
with transformations.
Oh,
Are you actually being serious?
Being very serious.
why did you do that? If you do that, I feel like we
I feel like I'm the teacher and I'm gonna do what I want to do.
Yes.
All right, and that's our h of x. You shouldn't need me to plot points. You should be able to plot points on your own.
I don't know how to plot points.
That's a different day conversation. All right, how do we feel about horizontal and vertical shifts? That took a little longer than I anticipated. Yeah.
It's so much time for us to pack up and go to our next class.
I think it is, but all right. I know.